pretty easy concept here. So congruent figures, what do you think congruent figures, what does that mean? They're exactly the same, like all the sides are equal measurements, right? All the angles are the same. So if I took my two congruent figures and I put them exactly on top of each other, they would exactly match up. Does that make sense? Okay, that's what a congruent figure is. So it says they have corresponding congruent parts. In other words, they have three congruent sides, three congruent angles. Oops, I said three, but they have congruent sides and congruent angles. That was congruent triangles have three. So in this case, with our two polygons here, right, I actually have four congruent angles and four congruent sides. So our congruent statement is going to be like A, B, C, D is congruent to, and then the order that we put the letters in matters. So if this angle looks like it matches up with this angle, then I do X first. If B looks like it matches up with W, then I do W next. Does that make sense? So it looks like maybe C is next, and that looks like it matches up with Y. Did I do them in the wrong? I think it should be WX, actually. WX. See, I gotta like rotate it to put it on W. Is it WZ? Is that the issue? Man, I'm struggling on this. All right, let's do the ones we definitely know.
It's WXYZ.
I definitely know the C and Z should match up. Or, no, I don't. C and Y. Woo! All right, what else?
Z and D.
I think it is WXYZ. I think I did it in alphabetical order. Isn't that nice of me? All right, so I think it's A, B, C, D, and then it's W, X, Y, and Z. But we should always check that because they're not always the same. So W, X, Y, and Z. So imagine cutting it out and rotating it and putting it directly on top of the other one. Does that make sense? So our congruent parts. So let's talk about AD. What do you think segment AD is matching up with? Look at the first and last letter. That's how we're going to tell. No? Oh, yeah, WZ, but we're going to write WZ, right? So we're going to say AD and WZ match up. Okay, how about the next side? So how about DC? What do we think DC matches up with? Yeah, we're going to say ZY. How about CB or BC? Doesn't matter which way you do it for the first one, but if you do C and then B for the next one, what do we have, Rhett?
Oh, I just have a question.
Yeah?
So when you're doing it like this, does the order matter?
The order of the letters is going to matter. So when I say like A, B, I want to make sure that I say WX in the next one.
Okay.
Yeah. All right, and then there's one more. Do we see it?
BA.
Yeah, so BA, and it's going to match up with XW. Does it make sense? All right, so those are all the sides that match up. How about all the angles? So angle A matches up with angle W. Angle B matches up with angle X. Angle C matches up with angle Y. And angle D matches up with angle Z. Make sense? All right. Yeah, sort of. So what if we have triangles? So if I have triangle X, I wrote A though, X, B, D, and I have triangle A, M, L, and I wrote them in that certain order, so I said that X, B, D, and A, M, L matched up. That means that angle A has to match up with angle X, right? Do you guys see it? And then angle B and angle M. And angle D and angle L. So you don't even really need to draw the pictures out because you should be able to tell just from where the letters are placed. Okay, so the first letters match up, the middle letters match up, the last letters match up. Do you see it? So right from there, I could say, oh, angle X is congruent to angle A because they were both the first letters. And then I could say angle B matches up with angle M. And I could say angle D matches up with angle L. So those are the three congruent angles. So then the three congruent sides are going to be X, B, and AM. So I did first and second with first and second. What if I did XD? What would it match up with? Yeah, AL. And then one other side. Can I say DX? What about DX? Haven't I already kind of used that side? Do you guys see what I'm saying? Yeah, so what do I need then? Yeah, BD. And it matches up with ML. Making sense? All right, so the third angles theorem. So let's think about this. So let's say that I knew that this one was 85, and I knew that this one was 55. So if I know that this one is also 85 and this is 55, that means that they sum to be 140, right? The 85 and 55 is 140. The other one has 140. What's that third angle have to be then? 40. And is it the same for both of them?
Yeah.
Yeah. So if you have markings that say two of your angles are the same in a triangle, in two triangles, does that make sense? Then that means that the third angle has to be congruent as well. Okay, it doesn't necessarily mean that triangles are congruent though. So we're going to talk about congruent triangles throughout this chapter. So let me show you a picture. What if I had this little triangle here and this big triangle here, and I knew that these two were congruent? Does that third angle, I mean the third angles are the same, right?
Yeah.
So I can say that angle and that angle are the same. But are the triangles exactly the same where I could cut them out and put them on top of each other and they'd be the same? No, clearly not, right? But I could have two triangles that look the same but are just different sizes. That's going to be what we call similar triangles eventually. Okay? So number one, so it says find the value of the missing angles using the third angles theorem. So we have these markings that mean that our 35 is the same as this other one, 35. And then we have exactly the same markings over here. So that means those are both 35. So what's the measure of angle B and the measure of angle X? You can do this in your head. I trust you don't need the calculator, right? 110. Because they make 70 and you add them up. So that means the missing one is 110. They all add up to be 180 degrees, right? I don't know why my picture got shifted here, but my picture should be up there, but whatever. All right, so if I do my 30 and 102, so if I add those together, I get 132. So what if I did 180 minus 132? What am I left with? 48. Well, this next one has 102 and 48, so what's its missing one have to be? 30. Yeah, so we found all the missing angles. Does that make sense? Yeah, Cam, you with me? Cam, you good? All right, so let's use a paragraph proof. So you can always do a statements and reasons if you want to. Statements and reasons can sometimes be a little bit harder. But let's use a paragraph proof to explain why ABC is congruent to EDC. So the two triangles are congruent. So right now, what we know is that in order for triangles to be congruent, we need all three of the sides to match up and all three of the angles to match up. Okay, there's going to be some shortcuts in a little bit, but that's all we know right now, is that all three sides and all three angles have to match up. So what do I know with do you see the red angles that I have in my picture? Yeah. So how can I say that that's also 58? Yeah, by vertical angles, right? So we're going to say that angle DCE, and I'm going to put a little measure in front of it, is equal to 58 by vertical angles. Okay, so who can tell me why? Well, let's go ahead and find this. So I have 58 and 47. What's this angle here going to be?
That's going to be congruent to AB. I'm sorry, it's going to be equal to ABC.
Yeah, it's going to be the 75. How do you know it's the same though? I don't know. Yeah? It would be if we had some kind of marking to say that these were parallel. So he's saying, couldn't those be like alternate interior angles? If we had those were parallel, then definitely. But we don't have that. But we have some measurements, don't we?
Yeah.
Yeah, so what do you think, Rhett?
Oh,
Yeah, so we need to add it to 180. So we know that 58 plus 47 plus the measure of angle D has to equal 180, right? So if we solve that, 58 plus 47 is what, 105? 105? So if I subtract that over, 180 minus 105 is 75. So I have the measure of angle D is 75 degrees. Likewise, we can say, well, 58 plus 75 plus the measure of angle A also has to equal 180. And 58 and 75 add to be, what, 133? So when I subtract 133 from 180, I get 47. So this one has to be 47. So we're going to say that the measure of angle D is equal to 75, and the measure of angle A is equal to 47. And that theorem where we say that the angles add up to be 180 degrees has a name. Do you guys remember what it's named?
Triangle sum theorem?
Yeah, by the triangle sum theorem. Now, if you didn't remember the name, that's fine. You could always say, because all triangles add to be 180 degrees. All angles in a triangle add to be 180. Okay, so do we have all three of the angles are congruent? Yeah, so we have that angle A is congruent to angle E. We have angle B is congruent to angle D. And we have angle C is congruent to angle, well, I can't say angle C. I got to be careful with that, right? Because there's more than one angle C. So I'm going to say angle ACB is congruent to angle ECD. Now what about the sides? Because if I can get all three angles are the same in each triangle and all three pairs of sides are the same, then we can say all the triangles, like both the triangles are congruent, right? Are the sides all congruent? Yeah, that was kind of like given to us, right? So we know that AB is congruent to DE, right? Because they have the same measurement. And we knew that AC is congruent to EC, and BC is congruent to DC. That's a weird C. We're given. So once we've said all three pairs of angles are the same and all three pairs of sides are the same, then we know we're good. So we're going to say therefore. Do you guys know how to write therefore in math? It's like a little triangle. Yeah, therefore. That's read therefore. Did you guys know that? Yeah, there's lots of math symbols. Like I can write, for all real numbers, there exists x such that, like, that's math handwriting. Does that, like, make your head hurt? Yeah, that reads, for all real numbers, there exists x such that. Yeah, so therefore, I think we can handle the therefore, the little dots. All right, so therefore, triangle ABC is indeed congruent to triangle EDC, and we're good. Okay, that took a really long time. Do you guys agree?
Yeah.
Did you not like that?
No.
No. So there's shortcuts for this. We don't always have to go through every single thing. We don't have to say all three pairs of sides are congruent and all three pairs of angles are congruent. There's going to be some shortcuts. So one of them is going to be called side angle side. One's going to be side side side. One's going to be angle side angle and angle angle side. These are the things we're going to learn. Okay, but things like angle angle angle. Remember that example I showed you a little bit ago? You can have the same angles, but that doesn't mean that the triangles are congruent to each other, right? Does that make sense? So things like angle, angle, angle is not going to work. So we'll talk about which ones will work and which ones won't. And then that's the only things we're going to have to prove in order to say the triangles are congruent. Okay, so let's look at this one. Can we say that the triangles are congruent? So let's draw in some markings. Do we have all three pairs of angles the same? Not yet. How about these ones right here, right? Can we say those are the same? Yeah, by vertical angles. We'll just write vertical angles. Do we have all three sets of sides? Well, we have the 3's and the 4's, but I don't know this missing side, and I don't know this missing side. Can we get those? Look at our triangles. What's special about those triangles?
The right angle triangles.
Yeah, we have a right. So I can do 3, 4, and I can call this x. And I could find it. I could do, oh, x squared, my hypotenuse squared, is equal to my 2 legs squared added together. 3 squared plus 4 squared is 9 plus 16. So I think I heard Sophia already say, oh, it's going to be the square root of 25, which is 5, right? Did you say that? Was that you? So that's a special triangle in geometry. I use that all the time. That's a good triangle to know. So if you have a right triangle and you have 3 and 4, then the hypotenuse is 5. Okay? But be careful. Sometimes I trick you, and sometimes I put like things like 5 and 3, and then people are like, oh, that's going to be 4. Why can that not be 4? What's a hypotenuse? The longest side. So this can't be a 4 here. You would have to have the 5 here and the 4 here. Does that make sense? Okay, so we know that both of these are going to be 5 then because of the 3, 4, 5 right triangles. But we didn't even really need to find that number, I guess, because we already had those tick marks that said they were the congruent, right? So why are they congruent then? Because we have all 3 sets of angles, all 3 pairs of angles, and all 3 pairs of sides congruent. Okay, I won't make you write that out. It's fine. All right, so how about this one? Use the statements and reasons proof to explain why these are true. So we're going to go through all of them. So statements, reasons. What were we given first? So we were given that PQ is the same as PS. We were given that QR is the same as SR. We were given some angles too, right? So I'm going to say angle QPR is congruent to angle. So notice the order I went, QPR. So what am I going to do for this one? How about SPR? Do you guys see it? And we also know that angle Q is congruent to angle S. Why could I just do Q and S and not 3 letters on those? No other angles there, right? Q and S are the only angles. And all of that was given. Yay, step 1. That's a lot. So we got 2 pairs of sides, 2 sets, and we got 2 angles. So we only need 1 more side and 1 more angle. How do you think we're going to get the next side? What are the next sides I'm going to say are equal or congruent? Cam? Do you know it? So we had this and this. What's the missing side?
SR.
So we had this one and this one already. What side am I missing in each of those triangles? Yeah, PR. Is PR congruent to itself? Yeah. Why is PR congruent to itself? All right, you can write 1 of 2 things here. There's a property that we learned long ago. Reflexive property. Or if you're lazy, you can say same segment. I don't care. Right? Isn't that the exact same segment? Shouldn't it be congruent to itself? Yeah, but that's really called the reflexive property. That's the formal name. All right, and then we need 1 more angle. So we had, look at our triangle. We had this one and this one. What one are we missing? The one down here. Why can I say that this angle is congruent to this angle? Yep, exactly. Good. So we're going to say QRP is congruent to angle SRP. And that was by the third angles theorem. Therefore, triangle PQR is congruent to triangle PSR. And our reason is just going to be definition of congruent triangles. Right? Didn't we say congruent triangles have to have all the angles are congruent to each other, all the sides are congruent to each other. Okay. All right, easy enough? You guys think you can handle that? All right. Let me pass out your homework and you guys can get